Hey guys, hi, this is Deepak, and in this video, I'm gonna start off my discussions. I would call discussions on data science concepts. I'm not a tutor on data science, but I'm just learning and I wanna discuss what I'm learning. So here we go. So exploratory data analysis is one of the very important concepts if one is an doing data science, once one wants to learn data science, it is perhaps a very critical concept. It basically it allows you to explore the data before you start doing hardcore, very high level data analysis. You want to first understand the data properly, have some reasonable understanding of the data. So it involves you to like organize, it's like plotting the data. It's kind of like how you visualize the data, how do you summarize the data. So it is those are kind of the important aspects of exploratory data analysis. And a very famous guy called John Toole, famous statistician, he says that exploratory data analysis is can never be missed out. Although that exploratory data analysis can never tell you the full story, but it can always serve as a good foundation stone before doing more data analysis. So let us look at, say, there is some data like uh, 2008 election results for the swing states like Pennsylvania, Ohio, Virginia. So these are some of the states which affect the election results, it seems, in US. So let us see how it, let us try to do some, understand how the exploratory data analysis is kind of done on this data, which help us to do more analysis. So it is mainly, as I said, exploratory data analysis is visualizing the data. The first step is always to ensure you load the data into a Python object or like a pandas data frame. Pandas data frame, it is the first step. You get the data in row column format. You have the state, the name, you have county and the percentage of vote share for Obama. So you got that data first, then can design a histogram, create some histogram and analyze. And if you look at the default histogram which are created, you can see that 50% or most of the people in swing states did not vote for Obama. Did they voted for McCain? Okay, not for the Obama. As you can see that 40 to 52, less than 50, the number of values for Obama is more. So that means more people voted for his opponent than for Obama in the swing states, right? So that if when you look at this, you can immediately understand the data. But if you look here, you cannot looking at this, you can't understand the data. At least you cannot infer this information, right? So this is where the exploratory data analysis helps you out. So to create this graph, you can do it pretty easy using pandas, matplotlib library. So you need to just import the matplotlib. So here we are just importing the matplotlib, and then we are kind of defining a histogram for this column, which is the demographic share is the column name. We always give a x-axis label and a y label. Then we print it using the plot.show command. And plot, as you can see, is a reference for matplotlib.pyplot. So this acts as a reference. And so you can also see that if you change the bins, you can get a different analysis. Here you have 9 bins. When you have 9 bins, then your the analysis looks slightly different to there to more bins, right? So here with 9 bins, you can see that you can more you can you are inferring that most of the votes went for or Obama. So if you see this from the half, from 9, when you have 9 bins, you see more for Obama, right? But when you do it with 10 bins, so from this you can see that it looks more for this opponent, Bruce McCain. So you can although this can be a little confusing. So because here the middle point becomes 45 when you use 10 bins, uh, when you use 9 bins. So that is where the confusion lies. You are not able to clearly identify. So important to understand the number of bins that you are using, how many bins you are using. So with 10 bins, you get the correct information that you want to analyze. So that's the thing, number of bins, one should understand that. And you can give the number of bins by giving an array of the bins in this. So you can say bin equal to this array bin edges, which can have the list of the values for bins. And internally it will count that, okay, there are 60, say for example 60 which are falling in the 42 50 bin. So it is gonna make a bar of 60. This could be say 40 or something, right? So like this, it is going to the matplotlib will calculate this and it will make a put that bar, create the bar accordingly. Pretty cool. I like it. It's pretty cool. But let me tell you something more cool than this. And here you can see if you increase the number of bins to 20, if you increase it, you get a more different type of graph. Little difficult to understand also, not that clear to understand. So So now comes a better solution for matplotlib, which is called Seaborn, which is a very nice graphical utility built on top of matplotlib, made by this PhD person called this guy Michael Wascom. Really brilliant guy, really amazing guy was developed this tool. I love it. So if you use the same thing, but in the Seaborn, when you say you import a Seaborn and refer at SNS and you set the Seaborn, it works on top of the matplotlib. It will work on top of it. It will help matplotlib to make a better graph. So when you use Seaborn to plot, you get a really cool graph. See the cool, it's so cool. It looks visualizing, appetizing, right? It looks nice, the graph, the axis, all that. So it is a very cool tool, the Seaborn utility that you can use. So let us kind of practice this quickly. So I'm gonna let us practice on a famous data set called Iris data set, which is you just Google Iris data set, you will know what it is. It is like the images of this particular species, Iris. Uh, Iris were just three species called versicolor, Sentosa, and Virginia and Virginica. So they have collected the data for around 50 samples of each of these. They have collected a 50 sample of uh, these nice looking flowers. The sepal, the width, length, and height of that um, flowers. So this is very popular sample data set for doing data analysis. And if we are gonna just import this, use the libraries that I just told, like the pyplot, seaborn, and we're gonna load this iris and import a library called numpy for numerical calculations. So simple. I'm just defining an array for the versicolor petal length. And in order to plot the hist, it is so simple. All you need to do is just, as it's mentioned here, use the plot plt.hist and type pass in the variable name for the versicolor. So first I'm using the sns.set to set it up, and on. Come on. It's taking time to load. Come on. Yeah, so it's loaded. And when I run this, yeah, so simple. I get this nice looking histogram. And you can easily, even I will give the labels like the Y label, X label, Y is the count, and X is the petal length. And I do that. I will just specify plt.x label, plt.y label. I get this also, right? It's pretty cool. And the number of bins, we can give a change the bins also. So typically the number of bins, which is a good number, is a square root of the number of the data points. In our case, say 50 is the data point, 150. So 150 square root is roughly 11 or something. So let us use the np dot square root to find um, a number of bins. So if we look at the n data, which should be number of data points will be like close to 50 data points. And if you look, I got a number of data to be length of the vesicular petal length array. So 50 square root is 7. We're going to convert into int. And then when we pass the number of bins, we're going to get this result with having the number of bins. Okay, so what is this error? I didn't have this variable. Yeah, now it is coming. Yeah, so it's cool, right? So thank you for watching and have a nice day. Bye for now. Please do like and subscribe my channel anyways. Thank you.